Hello. So this question is asking us to graph the first and second derivative of these two functions. The first question I like to ask myself when approaching this kind of problem is, would it be helpful to break up this problem or these graphs into several parts? Now, for this first graph, I think it would be just fine to do it all in one fell swoop. But in the second one, I think we'll have more luck breaking it up into several parts. And I'll explain why in a little bit. So for the first graph, it helps to take a look at the starting and ending points of the graph to see what the slopes are at those points, so we can graph them onto the first and then the second derivative. So for this first graph, it looks like the graph starts with a negative slope, and then at the end, it has a positive slope. So it has a negative slope here and a positive slope here. So we know that when we're graphing this on our first derivative, it's going to start with a negative slope, maybe somewhere around here, and it's going to finish with a positive slope, somewhere around here. Now, it's also the case that this graph has a critical point right in the middle. So right along this point, when x is equal to 0, the slope is also equal to 0. You can see that it's a flat line right there. So we know that at x equals 0, our slope is also going to equal 0. So our first derivative is going to equal 0 as well. So now that we have these 3 points, we can just draw in the rest of the graph, which is something that starts off very negative, eventually hits 0 at 0, and then becomes more positive at a constant rate. So our slope is going to look a little something like this, a straight line from negative to positive with a point at 0, 0. Now, in order to graph the second derivative of a function, all we need to do is graph the derivative of the first derivative. So if we look at this first derivative graph that we have here, we can see that it's just a straight line. Now, something you should note about straight lines is that their slope is always constant. That is, the slope anywhere on the graph, like right here, it's going to be the same as the slope up at this point here, because it's a straight line. So if we look at this graph here, it has a positive slope that is a straight line. Therefore, the slope is just going to be a straight line. Oh, sorry, I should do that with the line tool. The slope is just going to be a straight line in the positive sector of the graph. Now let's move on to the next one. So the next one's a little trickier. I think it'll be helpful to break this one up into parts, wherever there are these points here on the graph. So in order to do the first part of this graph, let's take a look at where it starts. It starts at a really, really positive slope and then moves a little less positive. So it starts up here. And then by the time we reach our break here, it's a little less positive, but it's still positive. So it ends right about there. So now let's use our line tool. Let's draw a line right there. So now the second part of the graph, the slope is actually negative, you can see. It's negative and it's a straight line. So like we talked about before, straight lines have a constant slope of a constant slope. So it's just going to be a straight line with no slope here. So because this is a constant negative slope, as in it's unchanging, we know that this is just going to be a straight line with no slope down here. Now finally, let's get to this third part of the graph, which has a positive slope that becomes even more positive. So you can see at the very bottom right here, the slope is positive, and then once we get to the end of this graph, it's even more positive. So we can start our final part of this graph positive, and then we know it's going to end up even more positive. So now we can just draw a line connecting those 2 points here. Now finally, the second derivative of this graph is just going to be the slopes of these lines here graphed onto the next one. So we can see here, this line here has a negative slope. So we know it's going to, and because it's a straight line, we know it's going to be a constant slope that's negative. So let me use the line tool for this. So right here, for this second line, we know it has a constant slope again, but this slope is always 0. You can see that the line starts and ends in exactly the same place and it doesn't move at all. So we know that this part of the graph has slope 0. And finally, just this last part of the graph is a straight line that has a positive slope. So we know straight lines are constant once more. So it's a constant positive slope. There you are. I really hope this helped. Please feel free to reach out in the comments if you have any more questions, and I'll go ahead and respond. Thanks so much.